Hi everybody, so this is going to be a video about test crossing. So how we use test crosses, actually it's more of a real life application, because if you were to come across an organism, say if you were to buy a dog and you're trying to figure out what the genotype is because you want to breed the dog, but you don't know what the genotype, but you know the phenotype because your dog looks brown or golden or whatnot. So how would you determine what the genotype is? And the process of determining the genotype is through test crossing. So we're going to go over two questions about test crosses. So let's look at the first one. A kid has brown eyes. It's a dominant trait, but we don't know if he is a heterozygous or homozygous dominant. How can we determine its genotype? So this is a very legitimate question, because you see somebody and you see that it has brown eyes and you know that it has a dominant trait. So what that means is that information tells you that the brown eyes, in order to get this brown eye phenotype, you could either be uppercase B or lowercase b, or another combination is that the other combination is that it could be both homozygous dominant genotype. So how would we figure this out? Well, the only really way to figure this out is to mate this organism or this kid with somebody. So one option is that if you were to take his genotype or take him right now and mate with somebody and look at the offspring, then you can basically, based on the offspring, determine what genotype this kid is. So let's put his genotype up at the top of this Punnett square setup. So here's my grid for my Punnett square. And for test crosses, is always going to be homozygous recessive, because this is the known genotype that you have to know. So this, your homozygous recessive, this is for your test crosses. So this is very important to know. Homozygous recessive. So you're always going to be crossing with a recessive trait. And once you fill in this Punnett square, you're going to see that this is going to be uppercase, lowercase, uppercase, lowercase, 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 oh, lowercase, and lowercase, like that. So this is one option. The next option is, well, what if the kid was brown eyes but had homozygous dominant? So then you're going to put this again, we're going to cross this with homozygous dominant. So here's uppercase, uppercase, and then I'm going to set up my Punnett square again, and then I'm going to put my homozygous recessive. This is my test crosses, and then I'm going to fill this in. So you're going to see that all of these ones are going to be your heterozygous genotype. So then what's the big deal out of these two options? Well, you can see that because you know the probability of the offspring, then you can look at your offspring and go back and determine the genotype. So what that means is that, okay, so if you were to get some offspring that had 100% brown, so if this were to be the case, if you had 5 kids with this kid and all of the kids had brown eyes, well, then you can see that, well, if you look at this Punnett square, this is 100% brown, so the kid must had homozygous dominant. But if you were to have 5 kids or 6 kids and whatnot, and the ratio of percentage were to be 50% brown and say 50% blue, and you can, because you had the blue, or even if you have to have one blue-eyed offspring, then you know that blue must have came from this one, from here. So then your kid's genotype must have been heterozygous genotype, uppercase and lowercase, because that's where the recessive gene came from. Okay, so that's what test crossing is. It's using your homozygous recessive. So let's try another question here. So this one is about border collies. A black coat is dominant to red coat. A breeder has a black male that has won numerous awards. The breeder would like to use the dog for breeding if he is purebred or uppercase homozygous dominant, uppercase B's. To learn this information, she test crosses him with a red female homozygous recessive. So you can see that this is like a real life example, because you have a dog but you don't know what it is. You know the phenotype, but you don't know the genotype. So let's try this out. For this to occur, you're going to have two different options, right? The border collie could either be heterozygous. This will still give you the black coat because you have your dominant, and you can also have homozygous dominant, this will still give you the black coat because it's, you have your dominant. You're going to test cross this with a homozygous recessive. You must know the genotype of this one in order to test cross. So there's my Punnett square, and then here's my test cross with my other Punnett square. So then fill in the combinations. So this is going to be uppercase, lowercase, uppercase, lowercase, lowercase, lowercase. And this one's going to be uppercase, lowercase, uppercase, lowercase. And you can see this is just exactly like the previous example, that you're going to look at your offspring and see that even if you were to get one offspring with the recessive gene, you know that your parent, your dog, was a heterozygous. You don't even have to have 10 offspring or 100 offspring to make this work, to look at the 50% ratio, because you just need one, and you know that because one, it had to be a heterozygous. Whereas that if you were to have a black coat on your first offspring, then you might want to do it again and test the next offspring, and if it's still black coat, then you might want to have a bigger sample size just so that you're 100% that there's no recessive gene. So if you're 100% of your offspring is 100% black, then you know for sure that your parent, that dog that you bred with, you started off with, had a genotype of homozygous dominant. So that's what test crossing is using what you have that you don't know as genotype and test crossing it with a homozygous recessive. That's the key. So that's your test cross video. Hopefully this video has helped you. See you next time.